Hey geometry class, this is your lesson on section 6.4. We're going to be proving triangles similar by side, 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 and side, angle, side, similarity postulates and theorems. So let's go ahead and get started. We're going to be applying the similarity postulates and theorems, and then we're also going to be, I have a proof for each of those theorems that we'll be using, the side, 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 and side, angle, side. So let's go ahead and get started. So before we start getting into the side, 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 and side angle side similarity theorems and postulates, we are going to get a warm-up here. The first two problems are a little warm-up that follow from the previous section that we looked at. So let's look at these. It says determine if the two triangles are similar. If they are, write a similarity statement. So far we have learned angle, angle, similarity postulate. That's it. These are our two new ones that we're going to be learning about, the side, 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 and side angle side. And then we'll be putting it all together in the next section. But so far, we've only learned angle, angle. So this one right here, can we prove these two triangles are congruent by angle, angle is what we're wondering. So on this one, well, we can say from this triangle, we know this right here, angle A is congruent to angle A. So both of these triangles have angle A in common. And then from here, this triangle has an angle of 55. And then the outer, bigger triangle has an angle of 55. So by angle, angle, yes, these two triangles are congruent. So writing a similarity statement will go something like this. The similarity statement, if you remember, is stating the two triangles that are similar to each other. So let's start out with angle A, E, and then B. Now go in that same order. So start with angle A, since angle A is congruent to angle A. And then what was congruent to E was D, so write that next. And then B is congruent to C, so write that next. And there you have it. There's our similarity statement for this. On the second one that I have for you, again, we're going to be applying the angle-angle similarity postulate to try to prove that these two triangles, the M and P right up here, and then XYP down here, are similar. So let's go ahead and apply that. We know these vertical angles are congruent. All vertical angles are congruent, as the postulate or theorem states. And then over here we have angle 55 and 70. Well, this one is 45. Well, that already tells you right off this angle is not congruent to either one of these. So we do not have similar triangles. So you don't necessarily have to do this, but I'm going to go ahead and state that this triangle MNP is not similar, that symbol there, to XYP. And put my little triangle symbol there. And I'm done. Okay, now let's move on to our new postulate or theorem here. All right, so here's another theorem along with the angle-angle that is going to help us in another way in proving that two triangles are similar to one another. And we call it side, side, side similarity theorem. And we just denote it in our proofs and things by SSS. Here's how it goes. If the corresponding side lengths, this means of all three triangles, if they all correspond, and the two triangles are proportional, then the triangles are similar. So this is about these two triangles down here. This is how this theorem right here applies. So if our AB, our side AB, right here, and the corresponding side RS is equal to, let's look at this, ST corresponds to BC, and then AC right here corresponds to RT. If we can show that this proportionality is true, that all of these proportions are equal to the same number, like the fractions reduce to the same number, then we can state that the two triangles are similar. And that's what this little symbol is right here. I know it didn't print out very well, but it's a similar statement there. Okay, so let's apply this. All right, so whenever we're applying the side-side-side similarity theorem, normally this is how your triangles are going to look. You're going to know all the side measurements of each of the triangles, but you're not going to know any of the angle measurements. So right off the bat, you should think, okay, I've got all three of my side measurements in each of my triangles. Let's try applying the side-side-side to show that these two triangles, or how many ever triangles you have, are similar to each other. Okay, so what this problem here is asking is either triangle DEF or triangle GHJ similar to ABC. So let's compare ABC to DEF, and then again ABC to GHJ. Okay, so this is how we're going to start. We're going to write the proportionality statement and see if all of the fractions that we have in our proportionality statement are equal to one another. So let's start by writing the shortest side of this triangle, which is 8, over the shortest side of this triangle, because they correspond to each other, over or under 8. That right there, to show that these two triangles are similar, we need to show that it's equal to the next shortest side over the next shortest side from the other triangle, so 12 over 9. And then again, one more time, because we have 3 sides to a triangle, AC, this right here, 16 over 12, because those are my 2 longest sides and they correspond to each other. Okay, so 16 over 12. Now, if you reduce this fraction, 8 over 6, that will get you 4/3. Reduce this fraction here, again, that gets you 4/3. So far so good. These two statements are correct, are equal to each other. Now, reduce this fraction, again, you get 4/3. So all three of these are equal to the reduction of 4/3. So this is true. All of these are equal to each other, so these two triangles, ABC and DEF, are similar. So let's go ahead and write that down. The triangle ABC is similar to triangle DEF. All right, now let's do this again, except let's compare ABC to GHJ. So again, shortest side over the other shortest side. So shortest side over here is 8. Shortest side over here is 8. Okay, let's keep on going. We now need to state the two middle side lengths. So 12 over 10. And then let's go ahead and do the last. So the biggest side, the largest side, is 16 over here and 16 over here. Now if we reduce this fraction 8 over 8, that gets us 1. Reduce this fraction 12 over 10, that gets us 1.2. And this fraction over here is 1 again. So none of these proportions, except for 8 over 8 and 16 over 16, are equal to each other. But they all three have to equal each other, or the statement, or the side-side-side is not true. They're not or similar triangles. So I'm going to go ahead and state triangle ABC is not similar to triangle GHJ. And then we're done with that one. So that is how we show the side-side-side similarity theorem in use here. This is how we're going to prove our triangles similar with side-side-side. All right, in this problem, just like the last one, notice we have side lengths being listed in each of our triangles. So we know we're going to be applying the side-side-side to this problem here. And in this problem, it is asking us to find the value of x. That makes ABC similar to DEF. Okay, there's actually a couple of different ways we can go about it, and I'll show you both of them. Just because we have an x value here and an x value here, there's two separate equations that we can set up, and they're both going to equal the same thing, and you will see that. So let's go ahead and set up their proportions because we're applying the side-side-side. So AB here, our shortest side on this triangle, corresponds to DE, so 12. So write those over each other, 4 over 12. And then come back to your small triangle over here. I'm going to do this side, BC, which is x minus 1. So let's set it to x minus 1 over its corresponding side. X minus 1 corresponds to EF, which is 18. Now we've got an equation. Let's solve for x. So in this one, if we multiply both sides by 18, because remember our variable here is in the numerator, we don't necessarily have to cross multiply. So let's multiply both sides by the 18 to get rid of it from this side. So on this side we have x minus 1. And then put these numbers all together, say 18 times 4 divided by 12, and you get the number 6. Now, solving for x now, we just need to add 1 to both sides, and we get 7 equals x, or x equals 7. And there we did. We solved for x. Now I'm going to show you using this side, df here, and solving for x. We are going to get the same value, but let's just do it. Again, let's put the shortest side over the shortest side from the other triangle. I'm just stating this over again, 4 over 12. And then now, from this triangle, DF corresponds to AC, so let's write the shortest side this from the small triangle over the larger triangle, because that's the way we did it first. Smaller triangle, larger triangle number. So 8 over 3 times x plus 1. Oop. Okay, so here, let's do cross multiplication. And you get, when you say this times this, we get 12 times x plus 1 equals, let's see, 12 times 8, that is 96. Let's see, 96. All right, divide both sides by 12 to get rid of it from over here. And now we have x plus 1 equals 8. And then that gives us, when we subtract 1 from both sides, again, x equals 7. So we got 7 both times. And that's what I told you from the beginning. We got x in 2 different cases here, but they both equal the same thing. Okay, let's go ahead and move on. All right, on this problem, it's a little bit tricky. So I'm going to show you on some problems, using this side-side-side similarity theorem in application to this problem here, you need to go ahead, if you have a statement like this, your similarity statement, write your statement of proportionality or proportionality statement, whichever way you want to say it, from the given two similar triangles that have been stated already. Okay, so let's go ahead and start the problem out with that. So we know, do the first two letters, AC, DC, put them over each other, C over DC. And then let's do the next two letters, CE over CB. And then the next two that come in line are E and A, B, D. So E, A, B, D. Okay, you'll see why I told you to write this out in just a bit. Now, also, it helps, like I've said before in class, to separate these triangles out in their own little drawings. So I'm going to do that and label them. This is just a smaller scale of ACE. And then let's do the other small triangle, which is CDB. All right, and let's label these triangles. So AC, don't have. BC we do. That's 10. See, BC is 10. And then CD we have is 14. And then we also have the length of CE. C to E are these two segments added together. So 14 plus 6, that is 20. All right. Now, another tricky thing on this one is we're asked to find length AB. Well, AB is right here. And how we're going to get AB is by finding this entire side length right here and then subtracting it by 10, and we've got AB. All right, so let's go ahead and do this. Let's find what AC is equal to. I'm going to call that my x, like right here. Let's call that our x. And set up our equation using this statement of proportionality that we wrote up here. So let's see if we have these side measurements, AC and DC. We have those. AC is x and DC is 14. So x over 14 is equal to, and in CE, we have that's 20, and BC, we have that's 10. So 20 over 10, there is an equation for us. We just need to now to do is solve for x by multiplying both sides by 14, and we get rid of 14 here, and we get x equals, now 20 over 10, that is 2. 2 times 14 is 28. So there we go. We found x is equal to 28, which that means AC, this whole side measurement right here, is 28 units. Now, hopefully you see why I told you to go ahead and write out your statement of proportionality to help you in writing your equation. Most of you probably would have seen this, maybe had drawn out this, and then you probably would have gone straight to, well, it should be x over 10 equals 20 over 14, which is nowhere near this right here. And if you wrote x over 10 is equal to 20 over 14, you would have got a totally different answer than this right here. So pay attention to these statements given to you. All right, now that we have our whole length of AC, we can figure out what AB is just by subtracting 10 from it. Subtract this segment length. So AB is equal to 18. And we're done. All right, on this thing, we are going to do a proof. Let's write statement or statements and reasons. That was not a straight line. A little bit better. Okay. So, first statement. One hint on this thing that I want to give to you before we go and prove that these two triangles ABC and EFD are congruent is from the beginning we are given that ABC is equilateral and then that DE and FE and EF are midsegments. And if you remember from the midsegment theorem, we're going to be applying that in this. So knowing this right here is going to help us in our proof. Okay, so let's go ahead and write down, well, if we know ABC is equilateral, then we should know that AB is equal to CB, and that is equal to AC. All sides are equal to each other or congruent. So using the definition of equilateral is what we did in that first reason. Okay, definition of equilateral triangles. Now in statement 2, I'm going to go ahead and list out that this is a given, that DE and FE and EF are midsegments. So DE, DF, and EF are mid segments. I'm going to abbreviate that. Okay, that is given. Now let's go to 3. From knowing that these are midsegments, we can apply the midsegment theorem. Now, you may need to go back and look this up, but midsegment theorem, from that, we can get this right here, that DE is equal to 1/2 its parallel side. So DE right here is 1/2 this side length, CB. And keep going around the triangle and cover all sides. So I'm going to make 3 statements here. Now DF is equal to 1/2 of, let's see, AB. And then the other one, I'm going to run out of space here. EF is equal to 1/2 of, let's see, EF, AC. Now, for the reason, it's because we are applying the midsegment theorem, because this is what is given to us in the midsegment theorem. So write midsegment theorem. All right, I'm going to make a new page and we'll get back to this. Just remember what we have previously written. Now, for statement number 4, which I'm going to do on the next page, this is where we're going to get our statement, is from this information right here. What we can do to show that each side of triangle ABC is proportional to triangle DEF, we need to solve each one of these equations by dividing both sides by CB, and then this one by AB, and then by AC. and you'll see where we go from that. So let's do that in the next step. So dividing both sides of the equation, we get DE over CB is equal to 1/2, and then DF over AB is equal to 1/2, and then the last statement is EF over AC is equal to 1/2. So in this, our reason is we divided both sides by those values, so division property is what we used. All right, and statement number 5, we can go ahead and say, well, since all of these proportions equals 1/2, then we could say this right here, that DE over CB is equal to DF over AB, and that's equal to EF over AC. Okay, and that is substitution property because we're substituting things in for 1/2. They all equal 1/2. You can even write that here if you want to. But anyway, so substitution. Oops. Well, I was right. Substitution property. There we go. And then the last statement that we actually need to make, because we know all sides of the triangle are proportional to each other and that all segments in an equilateral triangle are congruent. This statement right here, using side, 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 we just proved that triangle ABC is similar to triangle DEF. And we are done because by side, 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 we know this to be true. And this is the last or second to last statement that you will need to make whenever you are proving two triangles similar by side, side, side. You need to have this proportionality statement showing that all three sides are similar by stating their proportionality statement. And we're done with that one. Okay, so let's go on. All right, since we're here, finally, we're going to be learning about this theorem. It's called the side-angle side similarity theorem. So, much like it sounds, we're going to be showing that two sides from each triangle are proportional to each other. So, two corresponding sides from each triangle are proportional. And then their included angle, because A here is in the middle, that means this side right here and this side right here is proportional to these two sides, and their included angle is congruent. Then we can show that this right here is true, that the two triangles are similar. So let's look at this. If an angle from one triangle is congruent to an angle of a second triangle, and the lengths of the sides included, these angles are proportional. Oops. Tion. Then the triangles are similar. So what we're going to be proving to show that the two triangles are similar is that we need to make this statement that two of the angles are congruent, and it has to be the included angle, like this right here I showed you, and then that their two corresponding sides from each triangle are equal, their proportions are equal to each other, then the two triangles are similar. So let's apply this. All right, so in this example, it says show that ABC is congruent to DEC. Well, let's look at this. we know that this angle right here and this angle right here, they're vertical angles, so they are congruent. Let's go ahead and state that because we're going to need it in our showing process of um, showing that these are similar by side angle side. Okay, so angle ACB is congruent to angle, let's see, DCE. Okay, so we've got the included angle between our sides right here is congruent. Now let's show that the corresponding sides are proportional to each other. So on this triangle, this side is longer than this one, so let's set it up like that. The 18 over 30, those are the corresponding sides. And those two triangles. And then the shorter side right here, compare it to the shorter side over on this triangle. Just the same, so 9 over 15. Now reduce this fraction and then this fraction and see if they're equal to each other. If it's true, then we have similar triangles. So 18 over 30 and 9 over 15, they both reduce to 3 over 5. So it is true that this statement right here, it is equal to the same number, and their included angle are congruent. Their included angles are congruent. So yes, by side angle side, this triangle or these two triangles, ABC, is similar to DEF. And that is how you show it. You need to show it with these steps that I just showed here. All right, so here is another proof. Our last thing that we're going to be doing in this section lesson, or this lesson section, is prove this right here, that AZ times XY is equal to AB times ZY. And this right here, I'm going to restate, and you might understand it a little bit better. Another way to show that these two things are equal is by this proportionality right here, that AZ over ZY is equal to AB over XY. Okay, see how if we cross multiply AZ times XY right here, and that's equal to AB times ZY we get here. So this right here is going to be our second to last statement to get to this point right here. All right. So before we can actually show that their proportions are equal, we need to state that these two triangles that we see are similar to each other. Let's do that. And reasons. All right. So statement number 1, let's go ahead and write down the given information. Angle X is congruent to angle ZBA. So angle X, I'm going to mark those, and ZBA, this one right here. So we know two angles are congruent. Well, there is one other angle that they have in common that is congruent to itself, so write that down too. Say angle Z is congruent to angle Z. Oh, we need to write given. Well, we know angle Z is congruent to angle Z because, well, it is, and that is using the reflexive property. Remember, reflexive property states the obvious. Now, let's see. We know from each triangle that two angles are congruent to each other. So we have similar triangles here. Let's make that statement. That triangle, now from this, knowing the congruent angles, we know that, let's say, XZY is similar to, since we started with this angle, let's start with the congruent angle from the small triangle, BZA. So triangle BZA. Oh, no, let's draw number 4. And our statement, our reason for our statement is, well, we know these triangles are similar because of the angle-angle similarity postulate. So just write AA. Now on statement number 4 here, since we know the two triangles are congruent, then we know their corresponding sides are proportional. So make a statement of proportionality, and we only necessarily need for this one, for the proof, the two sides from each triangle that is listed up in here. So this statement right here. Let's go ahead and write that. So AZ over ZY. Sorry, I'm trying to write this a little bit smaller so we can fit it in. Then AB over XY. And the statement here, or the reason for the statement here is going to be, we know that they're similar. And by knowing that they're similar, which is definition of similar figures, we can show that these proportions are true. So by definition of similar figures. And then last statement here, number 5. Whoops. Number 5 is this right here. The AZ times XY, because we are cross multiplying here. So AZ times XY is equal to AB times ZY. And what you use there is multiplication. So, or cross multiplication. You can state cross multiplication, or you can just simply state multiplication property. And we are done, because we have proved our statement up here. Okay. All right. Sorry, I lied to you in your last slide there. We need to do this thing real quickly. It shouldn't take us too long. It says, can the two triangles shown be proved similar? If so, state the similarity and which similarity postulate or theorem you would use. Okay, so number 1, since we are given an angle in here and some sides, then right off the bat, you should think side, angle, side, okay? And that's how we're going to prove that these two triangles are similar. So let's see if their sides are proportional that we're given. So 6 over 12. And is that equal to 7 over 14? And this is true. They both equal 1/2. And since they're included angle B is congruent to angle F, we know that by side angle side triangle ABC is similar to triangle EFD. And we're done with that one. So let's look at this one. Okay, all side measurements are given in each of the triangles. So we're going to try to prove these two triangles similar by side, side, side. So let's set up their proportionalities. Okay, smallest side, smallest side. Okay, so 3 over 9. Is that equal to, okay, next to the smallest side, 6 and 18. So 6 over 18. And is that equal to 8 over 24? And the answer to that would be yes. All of these fractions reduce to 1/3. So we are good. So by side, 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 triangles, sorry, triangles IAGH is similar to, let's see, JLK. JLK. And we're done with that one. Okay, one more. We always know that vertical angles are congruent, and we have angles listed, no sides listed, so that is a clue to use something with just angles in it, like our angle-angle similarity postulate. And let's see. So this angle and this angle are both 40. Now, is this angle right here 80? And so take 40 and 60. All angles must add up to 180 in a triangle. So yes, 60 plus 40 is 100. Subtract that from 180, you get 80 degrees here, which means this angle and this angle are congruent, meaning the last two angles are going to be 60, and those are congruent. All of our angles are congruent, so by angle, angle, triangle, MNO is similar to triangle PQO. And there, finally, we are done. I do have one more thing for you all, which is this over here. You need to get out your own sheet of paper or something, or write on the back side of one of those sheets these problems right here and answer what I asked you to do. Just like the previous slide, if you want to go back to that and compare how I did those to what I want you to do on here, prove all of these triangles similar to each other by one of those similarity postulates that we have, or theorems that we have learned. You will use one of each, so that's a big hint. All of them are similar, so don't try just telling me, oh, they're not similar. I'm telling you right now, they're all similar. So prove that for me and show your work, and I will check that in class when we get back. So I see you all later. Goodbye, everybody.